If you click on this link here, it will take you into this area here, and so you have an idea kind of about what to expect when you're looking at the when we're going through our classes here. I haven't put the exams up here yet, but I will do, and I'll give you plenty of warning when they come up. But I wanted to give you an idea about what to expect week by week. So here we are. We've started the primary keys. We're going to be going into foreign keys today, and of course, there's a lot of query structure in there too. And we'll go into some joins and aggregates and other things too later on down the week. But these are the topics that I want you to know about. I'm hoping that the slides are sufficient here, but if you need more information about each of these topics here, you can find them in our books. I think we're on chapter 2 now. I didn't bother putting the chapters in here because I'm going to be skipping around, and I'm hoping that just by finding the actual topics, or if you've seen the slides themselves, the topics are there, so you can get an idea about where to go in the chapters to get more information. But the way that I'm putting my tests together and the labs, everything that you need to know is in the slides, and so I do hope that you use the slides as a, I guess, a Bible to the class, if that makes any sense. Anyhow, getting back to my website, I would like to show you that the videos for this class are now on my channel, and so you can click on the class videos button there. This class will also be on YouTube. I wonder whether that somehow rips a hole in the universe by watching a video on YouTube while filming it on YouTube. Does that damage anything? But for this course, you just click on the playlists, and then you'll find, for instance, if you're interested in looking at data analytics, those videos are there too, although that will not be on the test for this class. But you can click on the databases website here, or the slides, and then you can see that there's some, we have the slides for all the other classes. I'm trying to keep up with all the classes that we've been dealing with. All the videos from all the classes are here, and so I'm thinking that well, I think they're seemingly all there. Anyway, the ones that are the most recent ones are there anyway. I think there might be one missing that I'll have to go after, but maybe that doesn't really matter now. But I do encourage you, though, to look at these videos if you are, and I'm not doing this for likes, but if you are, if you're looking for, if you missed something in class or you need to go back and see where we are, or if life happens, as it tends to do, you can always go back and watch these videos, and they're all here available for you. Yeah, we have in fact, our video from last Friday is here. You can see that each video has a date, so that'll help you to kind of figure out where we are. And that date will be important because when you go to this planning your time here, you can get an idea about the dates up here. And so you can, in this column under date, you can see, for instance, more or less what we covered by the week. So I'm hoping that works. If you have any concerns, or if these videos could be better, or if anything could be better, please let me know. I'd be very interested in hearing your thoughts. And otherwise, I think I'll let you take it from there. Okay, so I'm going to close these videos down before they start playing, and then using up all my bandwidth for my computer here. Where we are today is we are talking about primarily keys. We're going to be talking about primary keys, and then we're going to be talking about foreign keys. And I'm hoping that by the end of today you have an idea about the difference between foreign keys and primary keys, because I think that they are actually a very important piece of working with databases. I wonder if I can move this a bit bigger here so that you can, maybe I can't do that. Page width. That's okay. I'll just see how that works out. Okay, so as you know, we've gone through these topics before, but I wanted to formalize what these keys are all about. And so as you know, primary keys we use to keep things unique. You wanted to make sure that if your columns have multiple values in them, like multiple redundancy, you don't want that to happen. You want to make sure that that doesn't happen. You want to make sure that all values are entirely unique. Now, I will say, though, that you may have one column in your table, which is your primary key, and you may have other columns which are not primary keys. Now, the other columns can be redundant. You can have, if you go down the column and you look at the values that are in there, you'll see that there's more than one reference to the same thing. But your primary key is going to be in your row, which prevents that column, or that tuple, I should say, from being redundant. So that means that you may have primary keys 1, 2, and 3, and in rows 1, 2, and 3, you have the same information except for the primary keys. And so because you have that one column here, you have this unique part of your table here. That means That means that your query can be made unique. Now, you want to have uniqueness in your tables because that's how you keep track of information here. That's how you keep track of each particular row of information. So as we mentioned before, like for instance, social security numbers, your telephone numbers, maybe even a serial number that's given. There's some number which is given out by database creators, such that that they use as a primary key. And so in this case, you might find at this college, your not your social security number, but your student number would be your identifying number in campus here. So there may be multiple John Smiths, but there's not multiple John Smiths with the same student number. And so that student number would be your acting primary key for the table of students at Allegheny College. Now that is different from a foreign key here. A foreign key. I'll just make this. Hopefully I can see that. A foreign key is slightly different because a foreign key is going to be a key that's in a different table that table A would have. And so the foreign key would be found in table B for table A, and that enforces a relationship between these two tables. So that is really what we're doing today. Our whole discussion is about, there's a number of things that we're going to be working with here, but the whole discussion is about how to use foreign keys to establish and enforce relationships between two different tables. Now, I think I've made the point before about how important these relationships are. They're absolutely fundamental. You have to have a relationship between tables in order for you to write your queries. So it allows you, in this case here, I like this word reference, it allows you to make a reference between one table and another, or a relationship. You also allow, for instance, types of integrity checking here. And what that means is, for instance, you cannot just add information, any old information, to a particular table if there's an enforced relationship between that table and another. So the relationship has to be respected, I guess, every time you use those two tables. Anytime you add information to those tables, the relationship must be there. Otherwise, you cannot add the information. Excuse me. So this foreign key, this is where the talent comes from when you're actually creating your databases, because you have to establish what that relationship is, and then you have to write the code to make the foreign key actually happen. Let's just move on here. So to give you an idea about how foreign keys and primary keys differ, I wish I could point to this, I just can't, but I'm looking at the employee table right now. And in the employee table here, you have the social security number of each employee who works for this company. You have their social security number, their employee number, their first name, their last name, the date of birth, and the date that they were employed. So this may be a table that the human resources may need to use. Now, the other table that we have is a table called orders. And this is the kind of table that you'd use if you are creating an order to buy some product. You may have to fill in some form, and that form ultimately would make, all that information from that form would ultimately make its way to this orders table. So you can see here we have the order number, the employee number, that's the employee who made this order. You have a customer number, that's probably who the order is going to. You have a supplier, you have price, and you have an item. So if you look at the red here, the primary key in the employees table here, you can see that the primary key is used to discern each row from every other row in this table. So I'm looking at the first entity right now, and I see AF 2343 2334, and that belongs to Manny Tomany here. That's someone's name. But if there's another person by the same name, they would have a different social security number. So therefore, your table would have a different social security number for that person. So that different social security number, even though the name is the same, that different social security would provide you with a different record of that other employee. In other words, now you know that you have two people working for you by the first name Manny. So your primary key makes this unique quality of each table. And you can see that in the orders table, you have a primary key, which looks to be the number of the order, how the orders were actually created. But one thing I would like to show you, though, is that the order number and the security and the social security number, there's no relationship between those numbers, because the social security number may be more kind of maybe it's a government given number, or maybe it's from the company. But the orders number, that comes out of if you are like maybe maybe when the order was actually created. Maybe the order was created, on Wednesday, and the next one was on Thursday, and so that's why they have order number one is the first one. The first row in orders is number one because that was on Wednesday, and then the next one was on Thursday. Who knows? It could be something like that. That's an internal thing. But the order number doesn't have that primary key for the order number and the primary key for the social security number in the employees table have nothing in common. And so you would create this thing called the foreign key, which establishes a relationship. Now, the relationship here is that in order to make an order, an employee must create that order. An employee must sign off on that order. The employee has to be responsible in some way. And so if you look at the green here, you'll see that the foreign key is pointing to the employee number in the orders key, or in the orders table here, and the also in the employee number in the employees table. Now, what this foreign key does, and you're probably thinking, well, that looks like a primary key, and what's different about that? Well, what this foreign key is doing is it's saying that you cannot fill in the orders table unless you have an employee number. So you cannot, so that means that an employee who has an active record in the employees table is the only time when information is able to be entered into the orders table. So you cannot have an order being filled by an employee who doesn't already have some entry in the employees table. And so that's what the foreign key is going to do. It ensures that the relationship that anyone who makes an order is an employee exists. That's your order. Now, I know that sounds like a mouthful here, but we have a bunch of examples that will help you to kind of see how that works. I have some code in your sandbox that I think that will make things much more interesting here for you. This is a schematic that you can look at or a schema. Sometimes you might call it schematic or schema. I've seen it both in different textbooks. I think they call it schema in our book. But this is this is basically what a database is going to look like. Now, these connections that you see between, hopefully you can see this here, but these connections that you can see between these tables are the relationships. Now, remember that in order for a table to be able to be a part of a database, there must be some connection between that table and the rest of the database in some way. It doesn't have to be a direct or efficient connection, but it does have to be a connection. So I'm looking now at the persons, medications, and scheduled medications. That link that we see between them is the relationship. Now, let's see, the primary key that I see is illustrated by that little key icon that's on the left of each word here. So in the person's medication, there's a primary key, which is person's medication ID. Now, person's medication ID also exists in the scheduled medications here. That is the relationship between these two tables here. So you can see how somebody put this thing together. And you can see that the other tables have similar types of relationships. This is just discussing how primary keys work. We don't see any foreign keys in this illustration just yet. But you can see that medication ID is in the medication table, and medication ID is also in the person medications table. So there is an established relationship. So whoever the group was who put this table together, they had to decide how these tables are going to be connected. So these are some more ideas about primary keys here. But the primary keys were established by people to create these relationships. And one thing I will say, though, is that this is one of the most important. I think everything else is redundant. We've already seen this before. But each table can have, at most, one primary key. So that's the one. So you'll see that in each of these tables here, that's why you only have one little key illustration or key icon next to each name here, because each table, by the way that SQLite works, is that you can only have one primary key. You can have as many unique constraints as you like. We discussed uniques on Friday last, where you can say that I want to make sure that there's no repetition for a particular attribute. But in terms of primary keys, each table gets one primary key. And if you try and add more information, if you try and add another piece of information to a table which already has an entrance for its primary key in that column, it's going to be rejected. So it is a violation for an insert statement to attempt a modification of a table content so that two or more rows have identical primary keys. Now remember, it's only the primary keys that are being checked to see whether they are redundant. Everything else in the table, if there's no unique tag, will basically be, it could be a repetition. But as long as those primary keys, the primary key values are singular, that means no repetition, then that's an acceptable addition or insertion into your table. Here is some code that we've seen before. I think that we've run many other pieces of code before that you can get an idea about. I'll just tell you what it does. We have two different tables here. One is called the reference, or residence table rather, residence, and the other one's called the guest. And so if you're running maybe a hotel or something where you want to make sure that every room is somehow matched with a person, you would have a very simple base that looks like this. And so what we're doing in this one here is that we have these insertion lines, and these insertion lines are then going to put in, for instance, you have Sherlock Holmes, you have his address, 221B Baker Street, of course, and his number is naturally 221. That's his address. I'm a big Sherlockian, so in case you've probably seen this happen before, but Sherlock Holmes comes up a lot in this class. So you have the first guest here that I'm inserting, and the second guest is Amelia Earhart. She lives at 1 Airway Street. And then I'm going to be putting both of these people into my residence table, and I'm going to be connecting them by this number here. So Sherlock gets 221, that's his special ID number. And you'll see that in my table, there's a primary key for residence, and there's a primary key for my guests. And so that's how I ensure that if I have two people who have the same name, Amelia Earhart, then I know which Amelia Earhart it is because each person has their own primary key. And we've seen this before, and so I do encourage you to play with this code. Now, this contrasts with foreign keys. So we're going to be kind of zipping away here. We'll be talking about each of these things back and forth. But a foreign key, I'll just put the definition that I found online here at the SQL website here. A foreign key is a way to enforce referential integrity within your SQLite database. A foreign key means that values in one table must also appear in another table. We discussed that. So in order for you to enter information into the first table, you must ensure that that relationship exists in the other table before you can enter that information in. The reference table is called the parent table, while the table with a foreign key is called the child table. It's a very nice family-friendly name there. But essentially, it is an enforced relationship between two tables. And you'd use that because if you have people adding things to your database, you want to make sure that your data doesn't become corrupted by somebody adding information where it shouldn't be. And so you'd say, in order for this information to be added, I'm going to enforce a check, and that is that this table has to have that information, and then this table can then go ahead and add that information. But unless I have information, unless that connection exists, then I'm not going to be able to do this. I won't be able to add my information. So you're making your database behave according to established relationship rules between these tables here. So let's look at this code right here. I'm going to go to my prompt here. Hopefully I can get there, you can see it. And by the way, you've probably by now noticed that in your sandbox, oops, I can't get there just yet. I have to go to some other stuff. Where am I here? Okay, let me just get to my, sorry, let's get to my, where I'm keeping my files here. Fall, and then I have K12, I have lessons, class docs, lessons. This is the fourth thing here, and then I have, these are your slides from today. You'll notice the date. But if you go into the sandbox, I have a whole bunch of more Docker files. Congratulations. Now I'm hoping that this actually does make some difference here. I'm still getting some messages from some of our colleagues who are having some trouble. So I'm hoping that if you have a Mac machine, that you'll run this command here to build your Docker. If you have a Linux machine, you'll use this command. They're really the same, but there's some minor differences. If you have a Windows machine, you can use this command here. So I'm going to just show you how I'm going to get into Docker. I'm using a Mac right now, and so I'm going to have to first of all build my Mac thing here, and you'll see that I've already built this, and so nothing too fancy is going to happen. But then once I've created my Docker container, then I need to run it using this command right here, run. So run Mac, and then there we go. So you should see a prompt that looks like this, where you have someone called root Root means it's like the super user. It's the person who's in charge. And I think that I'm perhaps speaking to things that you already know. I think everyone, but if you still have questions, then please get in touch with me and we'll find a way through this. Now, you should be able to see your files. When you go into the source directory here, I think you'll see some other stuff that you can play with. There's some code, and there's a builder. And so you should be able to actually get into, if you just type in SQLite 3, you should be able to get into your container here, or your container's version of SQLite, which is actually not bad because this is one of the more recent versions of this thing here. So it might be more recent than if you're using your Mac, for instance, and you have SQLite on there. You might find that your container actually has a more up and current version of SQLite. Okay, so what? Let me just go back to these things here. So the code I'm looking at here is this. I'm just going to dump this in and then play with it there. Now, when you're using foreign keys here, it's absolutely essential that you have this piece of code at the very beginning of your database. Pragma foreign keys equals on. What that means is that it starts enforcing the relationships that we have established by our foreign keys. So I'm going to go and copy this. I can't quite get the other piece just yet. I'll go back here, I'll go down there, and hopefully you can see me. Everyone see what I'm typing in? Maybe I should. Hang on. Let me just make this. Oops. I'm going to change my window just a little bit so you can see what I'm typing in here. Oops. Maybe I don't need to do that just yet. I'm not typing in yet. Okay. I'll make that's okay. And if I just go ahead and paste this in there. Good. Oh, you know what? I don't think I can just dump everything in. I'm going to have to do it line by line. So what? I'll show you how to do that. Let's go back to those slides. And I think we have to do it line by line. For some reason, I can't just dump things in as I would normally do. Apologies. So that's the first line. I'll go back here. I'm going to take this code. Oops. For some reason here, just put the D in there. And oops, put the D in there, and I'll go ahead and put paste. Put that in there, and hopefully that will work. Noted table car. Okay, so that should have worked by now. Oh God, what's going on here? Can I not create my table here? What is the deal? Why does this not create? Okay, so I guess it does work. I guess that line by line it doesn't seem to work, but I do have I think that you have code here that gives you all this information here, so you should be able to just copy and paste that code. I think that since I've started this way, I'll just continue this way. I'm going to do the next table now. You can see right here. And then I'm going to go back over here. I'm going to paste that in here. And hopefully this works. There we go. Agent and car. So I can do my schema. And you should now see that we have the car table. And we have the agent table. Everyone see that? Everyone there? It's kind of a strange way of doing this, but still. I think that when you're actually creating a real database here, you would not copy and paste into a database in this way here. Instead, what you would do is you would actually create a text file, like a builder, like what we've done in class already, and that you'd have your table creation. Now, let's go ahead and put some information here. So hopefully you can see me copying and pasting some of these lines here. I think I may have to go line by line, which is just really incredible. Actually, do I have this? Maybe. Hang on, everybody. Let me just see whether I have this code just waiting here that I can just pick up here. Sorry, let me just. You can't see me just yet. I'm trying to establish my. I'm looking for these files in my editor. If you can copy and paste it, that would be fine. Okay, so I'm going to try and go to my editor. Hopefully you can see where I am. Oops, you can't see where I am just yet. I have to establish my editor. Goodness gracious, why is that not showing up now? Oops. There we go. There we go. It's a bit big, but okay. Wow, this is definitely so extraordinarily large. Okay, so hopefully everyone can see that. And if I make this bigger, does that make any difference here? Okay, good. Now I'm going to go to my sandbox and I'm going to pick out my source, and I think that I have my agent cars, and that should be this. That should be this text right here. And so if you're having trouble copying and pasting from the slides, I thought I could get this done without this, but I guess this is probably the best way of doing it. So we've already put in our tables in, which is right here, and now we're going to put in our. Hope you can all see this. I'm going to put in my actual information here. Now, let's just go back to look at this code for a second here. So I have a name, which is a primary key. That's fine. That's a very simple database. It's not the best way of making a primary key, by the way, because a name could be, you can see how that might be repeated in some way. In my agents table, I have a primary key as an ID, which is important. But the thing we're talking about is the foreign key. And the foreign key says, okay, we're going to call this name here registration. That's what the agent table will refer to this foreign key as, registration. That's like the variable name, if you will. Now, this piece over here, references, that means go and find this table here, car, which is up here. Find the car table and look at the name attribute, which is right here. So what this is saying here now is that anybody that I add, any agent that I add to my agents table, must have, for instance, some reference. Their name must be in the car table. Must be there. So let's just go ahead and do this here. I'm going to be putting in, for instance, these two lines here. Let me go back and show you what I. Oops, you've already seen that part. Sorry. Go back to my terminal, and when I just paste this into my terminal, hopefully it'll just paste without any trouble. Good. So my tables are still there. I can just select all from car and see who's in there. I have Aston Martin, MI6 to 130. Let's see what's going on in the agent table. Oops, agent, sorry. And I have Bond. He's in there. It's Bond. It's always Bond. He's back. So this is the connection here. So going back to my thing here, so I'm looking at, remember, in my agents table here, the name must be the name Bond. Let's see, where are we now? Let's get kind of messy here. Let's get these tables back up again. So I have car, agent. So the name of my agent's table here must be already the car table. So I'm just trying to find this here. So I guess it's the right here. I guess it's Bond. No, sorry, Aston Martin. It's the name of the car. So the name of the car must be in the other table here. It must be in the car table. So in order to add an agent here, they must already have a car. So you can see that Aston Martin here is in car, and Aston Martin is also an agent. And so this connection here must exist. That means this information from Aston Martin, or this name Aston Martin, must exist in car, and it must also then, if it's in car, then you can add it as your agent here. Now let me just go ahead and change something here. I know that we're kind of, I think the slides here actually have an example here where we can see this. Going back to my slides, if I add, for instance, a new agent here who's driving a Buick, let's just go ahead and say I'm adding 007 here. Everything else seems to be the same. I've just changed things around a little bit. But he's now driving a Buick. We'll see whether we can just go ahead and put that in here without any trouble. So let's see what happens here. Okay, so, oops, sorry. There we go. Sorry. So when I just copied this in there, you can see that there was this foreign key constraint failed. What does that mean? That means that this word here, Buick, didn't exist in the car table. Oops, select all. That means that I need to have a reference here to Buick in order for this reference here, in order for this tuple to be added. So let's just go ahead and try that and see what happens. So I'll go back to my slides for a second. In fact, actually, I'll go back to my editor. Maybe that's even better. So I can work from that. And if I go back to my editor, you'll see that I'm going to insert a car reference here. So I'm going to say, okay, the relationship is that the car or the name of the car and the name and that name of the car exists in both tables. So if I go back to my editor or my terminal and dump that new reference in, To show you, select all from car. We'll see now that we have Buick in there. And I'll just show you before and after here. Select all from agent. So let's go back to that thing here that was working before. Where is that here? So I'm going to insert into my agent table here this new reference, and the reference, the foreign key, is going to be on the name here. So that means that this Buick, the name Buick, must exist in the table, the car table. And when I push enter, it's accepted. So now you can see that the agent table now has this new tuple here. And that is because Buick exists in this table, and it also exists in this table too. So I hope that that's kind of give you an idea about what's going on. I know that there are still questions here, but what this really means is that in order for me to add any information into my my table here, my agent table, the car had to be already registered in the other table. And so that's what your foreign key is doing. It's like it's creating a rule, and that rule has to be adhered to. Otherwise, you cannot install any information in this table unless that rule is met. So I can go ahead and add, going back to my table here. You can just play around with this if you'd like. But for instance, I can go back to agents here, and I can put as many. Actually, this will fail because the constraint, the ID, is the same here. That's my primary key failing. But if I go back and change my primary key, I'll just say, for instance, I'll just put 1 in here. I'll put 2 here, for instance. I'll just show you what I can do. And 3. I can keep adding all these things in here as much as I can put as many things as I wanted here because the relationship is being met according to the primary key. In other words, the relationship is that each of these members here has a car which is already registered in the car table. Now I know this seems like a really roundabout way of explaining this, but as long as you just remember that there's a relationship which exists between two tables here, and as long as that relationship exists, then you can enter the information. But if I'm trying to enter information here, for instance, let's say it's not Buick anymore, if I'm trying to enter like BMW, then it's not going, actually the primary key failed. Let's put 4 here. But the foreign key is going to fail though, because it's saying, wait a minute, you're talking about entering a car in this table, which I have no reference to in the other table. And so that's the essence of what these keys are all about. Okay, so you can add some other things you can play with here. I have like another one here called Rusty Truck. You can't actually add any information into your database for Rufus and his Rusty Truck. You can't add that information into the agent's table until Rusty Truck is registered. And so you might think about how you use this in the real world. If you're a bank, for instance, in order for somebody to have a bank account, they have to first have a savings account or something. Maybe you have restrictions on how people can use the banking. Or maybe, for instance, before people can work at your company, they have to go through some kind of a screening process, or they have to be added to a certain table to say that they are, their health information is up to date or their insurance information is up to date. When that information has been entered into a table, then other tables can be added, or the other tables can be edited with their information to show that they are now employees. And so you would do that to create some kind of a, to ensure that the information that goes into your database behaves by specific rules, which are absolutely essential to the company. Now, if nothing I've said makes any sense here, we have other examples to look at. In fact, it's right here. Another one is called the car color. And the car color, I do have code that's, I'm not going to put the code in your slides here. But I wanted to spend some time actually talking about the car color code. Kind of hard to say, but hopefully you'll get that. Let me go back to my, my editor here, and you'll see what it is that we're doing. So in my editor, get back to my thing here, we have this car color code. Now, when you click on this, you can see the code here. This is a new database, but this is a different type of thing here. And so what we have is that in order for a car to be added into a table here, which is called cars FK or foreign key, that the color of that car has to be registered already in a table called colors. I'm spelling colors with the British English spelling to make it a little bit more interesting, just to keep everyone's eyes being raised, just to be interesting. But otherwise, though, it doesn't really matter. I'm putting, actually, I spelled it that way so that you don't confuse colors with maybe perhaps the a keyword that's called colors that you often see in computer programming languages. You don't usually see this colors with OURs as a keyword in programming languages. But we have a table here, and I'll just show you how I'm going to do this here. I'm going to go back to my slide or where I'm working here. I'm going to exit this SQL. I'm going to go inside, and maybe I'll hold on to this database. I'll call this cars colors DB. This is how you'd actually create a database if you are just free-handedly entering things into your database. Give it a file name, press enter, go back to your slides, and start working. Don't forget, though, that you must have this first line of code here. That must be turned on in order for the foreign keys to work. Otherwise, you could build your tables and you could populate them as you would, but if you don't have this code in place, then SQLite doesn't care and it doesn't maintain that relationship. So you can have all kinds of faults. And so you want to put that line in as the first thing. The next thing I'm going to do is I'm going to just take some code here. I'm making a color table, and in my table I have the colors red, green, blue, and cyan. Who doesn't love a car that's cyan? just imagining how that would look on the road. Really, really bright. And so the data has gone in. I can do a tables. I can show you the tables themselves. There it is. I can show you what's inside the tables here by a select. So you can see that the colors are actually there. This table only has colors. That's all it is. Now, going back to my editor here, I'm going to create another table. And this is going to be a table which, let's just look at this for a second and see what we've got. We've got tables that contain the model of a car, which is a string. We have the year of the car, which is an integer. And then we have the color of the car, which is another string. But this is the foreign key because this is going to be referencing. It's another way of doing it, but it references the color or the name of the color in the colors table, which is up here. So in other words, name, what is name? Name is, if you can see this, that's actually the attribute in colors. And so I've said references. I'm choosing, it's a slightly different way of establishing the foreign key. I know we had the word foreign key before, but this works just the same. There are some minor differences, but we don't need to concern ourselves with those just right now. But this will create the same kind of effect here, where it's going to the colors table, and then it's going to be looking for this attribute name. And provided that the information that I'm adding into this cars FK table has the color, which is the same as the color in the colors table, then I'm able to submit these records. And so I'll just go ahead and do this. So I have the first thing. I have a Subaru, which is blue. I have a Ford, which is red. A Chevy, which is blue, a Toyota, which is green, and another Toyota, which is red. Now, these colors exist up here already. I have red, green, blue, and cyan. And so this is saying that any car can be submitted as long as that color exists in my colors table. So let's just try and see what happens when I go ahead and put in these first ones here and get an idea. So there's going to be an error that you'll see popping out at you, and it's up to you. Oops, you know what? I didn't put my table yet. How stupid of me. Let me just do that first. What happens in Alden 101 stays in Alden 101. Okay, so I've just created my table. As you can see up here, you can type in the .tables command and see that it's there. And if I put this last command in here, there's an error. Why? Anybody? What happened? Why is it that this, I have red here. Oops. I have red in my table, and I'm trying to enter a car that's also red, but there's something that's not working. Who can spot that error? I have made this error, by the way, countless times, and I think that when I started working with databases, this is the error that caught me up. Yes, sorry, Wes. Yes, so Wes has this is the R in red is capitalized. That's absolutely right. And so this is a mistake that I have made many, 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 many times. If you change the R to a lowercase r, then it will work. Remember, the word has to be exactly this. Now in SQLite, you're allowed to use upper and lowercase words when you write your code here. But when you are comparing, when you're using foreign keys, the R or the case of the letters in foreign keys must be respected. I know that sounds kind of like a, why do we worry about this now? It's just one of the rules. So you can use upper and lowercase values for like your design of the tables and the code and all that. But when you're actually using strings, it has to be the same thing. And I have spent hours, literally hours, trying to find errors that just basically came from the upper and lower case of a letter. So let's just go ahead and add some more information in here. So I'm going to take this. I have a Toyota car here, which, let's just say I have 5 Toyotas here, all from the same year, and they're all green. Can I add those? And if you see them right here, sorry, then you can. So I'm going to go back to my thing here. I'll select those. I'll select my work from the from my editor here. I'll go back here, and I'll dump them in here. And you can see that everything is swallowed. Everything is fine. Select from cars primary key, foreign key. And you can see that I can get redundancy here. Now, you want to avoid this redundancy here, but I'm not worrying about that in this case. If I had a primary key attached to all this, then I could, or a unique tag, or whatever it is, if I use either primary or unique, then I could avoid repetition here. But in this case, I'm not avoiding repetition. I don't care. It's just here. But if you're designing an efficient database here, you might have, for instance, another column in the in this particular table that would name like the number of cars that you have, rather than having a different reference for each one of these cars. They're all the same, so you might just say, well, I have, in this case, 5 Toyota 2016 green cars, whatever they may be. That would take up less memory than having to store 4 extra references of this. While the databases are small, it doesn't really matter, but when they get big, it will. Okay, let's go back to the notes here, and let's just try something else. And so I'm going to install, let's say that I'm working in this car company, and somebody asks me for a car that's called Chartreuse. Chartreuse is another kind of color, and so if I put Chartreuse into I put this insert in here, it's not going to work. It doesn't work because this color, Chartreuse, doesn't actually exist in my colors table. In other words, I need to have the reference Chartreuse in here in order for my reference or my insertion, this insertion, to work. And so what I need to do is I can go back, and in fact I even have the code, I'll just copy and paste it because I'm lazy. But I can just go ahead and add, for instance, do I even have it here? Well, maybe I'll make it up here. I'll just show you. Go back here, and I'm almost out of time, so I want to get this out of the way quickly. And I'll call this exactly the same way here. I'm just going to copy and paste it. And now, if I go back to like my colors, I'll see that Chartreuse actually does exist. So now, I'm able to add this Toyota. And by the way, I'm not trying to sell Toyotas or any particular kind of car here, but it works. I'm just using them as examples here. Select all from cars, foreign key. Okay. And you'll see now that I have this reference here. So there's a bunch of other things going on in the slides or in the editor that we're working with. You can look at these if you like. I think that we'll get to these in due course. The next thing we're going to be talking about is we're going to be adding some. For instance, you can create another table here. In fact, maybe I'll just add this in quickly just so you can get an idea. If I go back here, I can make another table here, and I'll call this CH. And what this will, I'll just paste this in there so you can see what it does. It should allow me to put some numbers in here. Foreign key, CH. Or so I guess I can add more information here. What does this actually do then? Oh, it's just another table. It's just another table, and what this table is doing is it is also using a foreign key to reference names. So that's, sorry, it's not adding numbers, we will add numbers. But what it's doing is it's adding, it's actually it's using the same, you can see this here, it's using the same foreign key that we have from the colors table. But here though, what this is actually saying is that we're able to actually add some information about, we're actually able to count. We can actually count how many times these particular cars have been added. But I don't think I have the code just yet to show you the counts just yet, but we'll get to that in due course. But anyway, but suffice it to know that in this particular in this particular case here, now we have two tables, cars FK1 and cars FKCH, two different tables here, which are both using primary or foreign keys to reference colors. And so you cannot add any information into these two tables here where the color hasn't already been added to colors. I know this sounds like a really roundabout way of explaining all this thing here, but I think that if you look at the code and you play around with it and you try and break it, then you'll see more or less what I'm talking about. But you would use this, though, when you're designing a more sophisticated database to ensure that certain relationships are met and they're not changed. One more thing I'll show you is, remember before when we first started this database here, I gave a file name. If I type in .exit, then I'm saving my file to this file right here. All the data that I've just entered into my database has been saved to this database here. And so this is actually a database, and you can see by the size, when I type in ls-l, you can see by the size that there is actually something in that database. And so if I go back again, and I type in SQLite followed by that name, that file name, press enter, I can type in .tables, and I can do even the search. In fact, I have my data is still there. And so this is how you can maintain a database here. It's all right there. And then to get out of your container, you type in .exit, and then you're back to where you came from. And sometimes you may have to add, if you're using a Unix machine, you may have to type in a password. And what that means is that your file, let me just show you quickly what I'm talking about here. The file that we just created, wherever that was, and I'm not in the right directory here. Shoot, where is it? Here. You'll see that this file now belongs to me. I've given myself ownership of this file. In Unix, if you make a file in your container, the file doesn't belong to you when you leave the container. Now it does. I'm going to end it here. We'll come back on Wednesday and talk more about using some primary keys and some foreign keys to create a rather sophisticated database. We're going to be talking about some new vocabulary, I think normalization and some other things too, to kind of things you should be thinking about as you're beginning to make a bigger and bigger database. As always, if you have any questions, please let me know, and I'd be very glad to field any questions that you may have. You can always hit me up on Slack or send me an email, or we have office hours. And thank you to the people who came to class today. I feel it. Take care, everybody. Be good. Stay well.
Thank you.